Welcome back to The Explainer, everyone. Today we are zooming in on a massive, absolutely fascinating pivot point in human thought. We're going to get into the brilliant mind of Gottfried Wilhelm Leibniz. Living from 1646 to 1716, Leibniz basically stood at this monumental crossroads in history, and he asked a question that would completely rewire how we think about logic. He started imagining something incredibly radical. What if human reasoning itself could be turned into a kind of mathematical calculation? It's a huge idea, and we're going to unpack exactly how he envisioned this revolutionary dream.
To really grasp why Leibniz's idea was such a game-changer, I want you to drop right into a universal problem we've all dealt with. Picture this. You've got two philosophers, or honestly, just two people on the internet today, endlessly, frustratingly disagreeing. How do you definitively resolve it? Historically, people would just argue verbally. They'd go back and forth, spinning in circles with messy, ambiguous language until everyone was just exhausted. There was absolutely no mechanical, objective way to prove who was actually right.
Okay, let's dive into this, because Leibniz had an unexpected, ultimate proposed solution to that exact problem. His answer was simply, let us calculate. Just imagine that for a second. Instead of raising our voices, instead of arguing in circles over the definitions of words, we could just sit down, translate our disagreement into a formal procedure, and literally calculate the correct answer. The whole messy debate would just evaporate into cold, hard, objective truth. It's an incredibly bold ambition.
Section 1. The Great Leibnizian Dream. So, where did this dream actually come from? Well, he pulled from two major intellectual traditions. From Aristotle, he inherited the idea that reasoning actually has objective forms, meaning certain logical inferences are valid completely regardless of who's saying them. And from Descartes, he inherited this burning ambition to find a method that guaranteed absolute certainty. Leibniz synthesized these ideas into a simple three-step formal procedure. Step 1, you represent concepts symbolically. Step 2, you represent the logical relations between those concepts. And step 3, you calculate the consequences. He was trying to transform those messy verbal arguments into a clean calculation, making him a true conceptual ancestor to the modern symbolic logic that runs our digital world today.
To pull this off, Leibniz mapped out two closely related projects. The first is his Characteristica Universalis. This was his vision for a universal symbolic language. Think about this. Instead of relying on everyday language with all its confusing double meanings and cultural baggage, what if every fundamental human concept could be assigned a very specific, precise, symbolic representation?
And that brings us to the second part of the dream, the calculus ratiocinator. If the first project gives us the alphabet and the vocabulary of symbols, this project is the engine. It's a calculus of reasoning. It means that once you have all those symbolic concepts, you can mechanically manipulate them to discover logical relations and find the truth. Together, the whole shebang forms a comprehensive system for literally calculating human thought.
Section 2, Math Meets Philosophy.
Now, what's really interesting about this is how much it leans on an analogy we already perfectly understand. Take the equation 2 plus 3 equals 5. We don't sit around and verbally debate what this statement means. We don't argue about the linguistic nuance of the number 2. The symbolic system of mathematics just allows us to operate on it objectively. Leibniz looked at this and thought, could we achieve something exactly like this but for reasoning itself? Which leads us to this massive, revolutionary question. On one hand, mathematics calculates quantities, and it does it flawlessly. But on the other hand, Leibniz asks, could logic calculate concepts and arguments the exact same way? If we can calculate amounts, why on earth can't we calculate ideas?
Section 3. Anticipating Modern Symbolic Logic.
Now, before we get too carried away, it is time for an important historical reality check. We have to separate what Leibniz actually achieved from what he merely anticipated. His true achievement was a massive paradigm shift. Aristotle had already shown that reasoning has form, but Leibniz? He moved the goalposts entirely. He shifted us away from viewing logic as just the analysis of reasoning and completely toward viewing logic as a symbolic system meant for mechanical manipulation.
But here's the reality. Leibniz did not actually create a complete modern formal system himself. He had extraordinary ideas, sure. He left behind brilliant fragments, ambitious projects, and some initial symbolic techniques, but it was a roster of later mathematical logicians, heavyweights like Boole, Frege, Peano, Russell, Hilbert, and Gödel, who actually developed the heavy mathematical machinery we use today to fully realize Leibniz's ambition.
Section 4, The Evolution of Logic and Language.
And this brilliantly illustrates one of the deepest continuous threads in the history of logic, the journey from natural language toward formal representation. It's like a historical relay race. We start with Aristotle focusing on terms and propositions, then the Stoics refine linguistic formulation, medieval logicians give us a highly sophisticated analysis of signs and terms, then right in the middle, Leibniz introduces the universal symbolic language. He passes the baton to Boole with algebraic symbols, which eventually culminates with Frege's formal language that can fully represent logical structure.
Section 5. The long historical timeline.
Let's move to and see how this builds across 6 major periods. Period 1 is Aristotle, connecting logic to structured reasoning. By period 2 with Bacon, logic connects with scientific method. Period 3, Descartes, ties logic to absolute certainty. Then we hit period 4 with Leibniz, where logic becomes all about symbolization. This leads straight to period 5 with Boole and calculation, and finally period 6, Frege and the modern formal system. That is the clear historical roadmap to modern mathematical logic.
Section 6. Grounding the dream in philosophy.
You have to remember, Leibniz was a philosopher through and through. You can't separate his concept of logic from his rationalist view of reality. He grounded his work in 3 foundational rules. First, the principle of identity, A is A. Second, the principle of non-contradiction. A proposition cannot be both true and false in the same respect. Now, those first 2 go way back to ancient philosophy. But the third one, the principle of sufficient reason, which says there must be a sufficient reason why something is so rather than otherwise, that is distinctly tied to Leibniz's own metaphysics. He literally believed the universe was perfectly logical, which is why a calculus could, in theory, explain it.
Section 7. Validity, certainty, and calculability.
So the crucial point is understanding that philosophers were often trying to solve different but overlapping problems. You do not want to mix these 3 concepts up. Validity just asks, does the conclusion logically follow from the premises? Certainty asks a totally different question. Do we have sufficient grounds for accepting those premises as true in the first place? And formal calculability, Leibniz's obsession, asks, can the reasoning be represented and manipulated within a formal symbolic system? They overlap, for sure, but they are absolutely different questions. The history of logic is just humanity gradually developing techniques for each one.
Which leaves us with this final thought. Leibniz sat there in the 17th century and dreamed of a universal symbolic language to calculate human thought. That's an idea that directly paved the way for the algorithms and AI defining our world today. So I have to ask you, if Leibniz dreamed up the calculus of human concepts over 300 years ago, what revolutionary formal systems are we yet to dream up today? What's the next great paradigm shift? Thanks for joining me on this explainer. Keep questioning, keep learning, and we'll catch you next time.